Okay, as we look at this one here, we need to go ahead and get this equation right here into standard form. Once again, since the x is not squared and the y is, it's going to be a parabola that opens sideways, and that standard form is an x equals. So we need to then complete the square with the y's because the y's were squared. To complete the square, once again, you got to get the variable that you're trying to complete with. Complete the square, in this case with the y's, all on the same side. So I'm going to have to add an x squared to both sides. I mean a y squared to both sides. We then have this. Now, we need to complete the square, but we need to do it when we have x on one side by itself, because we have x on one side by itself up here. So we got to get rid of the 4. So we're going to have to divide everything by 4. Well, in completing the square then, you want to complete the square with the y's. So I'm going to just group the y's together. So I'm putting parentheses around the y's. Notice instead of dividing by 4, I'm putting in timesing by 1/4. And you know 2 over 4 is 1/2. So just grouping the y's together, I have this. Well, we need to complete the square here, but to complete the square, we don't want to have a number in front of your y squared. So I'm going to pull 1/4 out of this. So 1/4 times what is y squared, and that's a y squared. Then you got to think of 1/4 times what is a half, and that is 2. So we have a 2y there. Still, there's nothing here. Still, there's nothing out back besides our 13/4. Well, we now need to do the half of b squared stuff. So we got to take half of our b and square it, and that's what we're going to put here. Then, what I put here, I then need to subtract at the end. So that's why I'm subtracting. It's really a 1 squared times what's in front of the parentheses of a 1/4. So I need to subtract by 1 squared times 1/4. So now I have my 1/4 here. Factor this. What's being squared in the beginning is a y. Take the first sign. What's being squared at the end is a 1. And then that's all squared. And then you'd have 13/4 minus 1/4, which is 12/4, which reduces down to 3. Now here you're given a problem in standard form. You're asked to find all this information of the vertex, axis, symmetry, focus, directrix, direction of opening, length of the lattice rectum. Oh, well, we know that since it's y equals in standard form, it's got to open in the direction of the y. So it's either going to open up or down. The number in front of your parentheses here is positive, so you know it's going to open in the positive direction then of the y. So in other words, it opens up. Your standard form then, when it's in the y direction, is y equals a times x minus h, all squared, plus k. Remember, your vertex then is always the hk. So h is in the parentheses with the x here. So it's the opposite of what's in the parentheses, the 1. The same as what's after the parentheses, the minus 5. Well, from here we should be able to go ahead and graph our parabola. We could either make a t-chart. We know the x-coordinate of our vertex is 1, so we could put 1 here and then choose 3 numbers on each side of it. Or you could use the idea of the pattern of 1, 3, 5, 7. However, keep in mind with that pattern, since there's a 2 in front, you'd have to double that. And so instead of over 1 up 1, you'd have to go over 1 up 2. Instead of over 1 up 3, you'd have to go over 1 up 6, and so on. When you plot your parabola, you ended up getting a parabola that looks like this blue one here. Your axis of symmetry is a line that cuts your parabola in half so that each side's the mirror image. Since it's opening up and down, our axis of symmetry has to go up and down. It's always going to go through your vertex. You know the x-coordinate of your vertex is 1. And that's what we had here. So this is x equals 1 for your axis of symmetry. Now, our latus rectum is always 1 over a in the absolute value. A is a 2, so it's 1 over 2, absolute value, so it's just 1/2. Now, to work with the focus in the directrix, the distance from the vertex to the directrix, or vertex to the focus, is always at 1 over 4a, and you always need to think of your a as being positive. In this case, a is 2, so it'd be 1 over 4 times 2, or 1/8. Now, remember your focus is always inside the curve of the parabola on your axis of symmetry. How far is it from your vertex? In this case, it's 1/8. So we'd have to go 1/8 up from your vertex. Your vertex is 1, comma, -5. You would then need to go 1/8 up, so you'd have to add that. So you'd be at -1, comma, 39/8. Take your -5 plus 1/8. The -5 is -40 over 8 plus your 1 over 8 is -39/8. Or you could just use your calculator and fractionize it. Your directrix is always perpendicular to your axis of symmetry, and it is always on the outside part of your parabola, never touches it or crosses it, so it's going to be 1/8 of a unit down. So if it's 1/8 of a unit down from your vertex was at a height of -5. You got to go 1/8 of a unit down, so subtract 1/8. Then you have your -40 over 8 minus 1 over 8, so you get -41 over 8, or you could just type it into your calculator.